Here we are on page 18, exponential functions and graphs. Graph labeling the horizontal asymptote in 1 point. Note the domain and range. We're doing numbers 1 through 12. Number 1, f of x equals 2 to the x power. So we're going to start up here. 2 to the x, 2 to the 0 power is 1, so it has the point 0, 1. We're going to start right there. And then as x increases, it's going to be 2 to the 2, 2 to the 3, 2 to the 4, and it's going to be an exponential. And then 2 to the negative powers, as we stick in negative x's, going to get smaller and smaller and head along to 0. We can see that the domain is going to be all real numbers, and the range is going to be, that's just going to be y bigger than 0. Notice that we don't actually hit 0. That's a horizontal asymptote of y equals 0. Good, that'll give us a good starting point for the rest of them. Number 2, g to the x equals 3 to the x plus 5. So we're going to start off with 3 to the x, and I'm going to put it here in a dashed one. It's going to go like that, and it's going to head along just like 2 to the x kind of looks like, but instead of 1, 2, it'll be up at 1, 3, and so on, but it has the same shape. Now we're going to add 5 to it, and when we add this 5 to it, it's going to take everything up 5. So we have a new horizontal asymptote of y equals 5. 0, 1 goes up to 0, 6, and then it's going to come down like that. Oh, there we go. 0, 6. Good. Labeling 1 point, the horizontal asymptote. Good. Now the domain, we still can stick in all real numbers, and the range is going to be the set of all y's such that y is bigger than 5. Yeah, we hit everything above 5. Good. Let's try the next one. Number 3. h of x is 4 to the x plus 3 minus 2. So in this case, here's 4 to the x. We'll go like this, and there we go, going through the point 0, 1, and we're going to watch where that goes. So we have here the plus 3 means it moves it 3 to the opposite direction, so it's going to move it 3 to the left, so we're going to follow that point right there, and it's still going to come down to 0, and it's going to shoot up something like that. There we go. And then the minus 2 is going to do something else. So that's our final one. So it's going to subtract 2. So instead of being at y equals 0, we're going to have this at y equals a negative 2. And this is going to go down here, down at negative 1. So we're back 3, and we're at negative 1. That's that point right there. And it's going to head there and then go up forever. There we go. So the domain on this guy is, again, all real numbers. Look at that. And range is going to be the set of all y such that y is bigger than negative 2. Good. Number 4. Here we're having g of x equals negative 2 to the x plus 4 power. So we're going to start at our 0, 1 and have a 2 to the x that we'll use as a basis right there. That's what exponentials look like with our 0, 1. Now let's watch where it goes. It's going to go left 4, so this plus 4 right here is going to make it go opposite of what it looks like because it's affecting the x. Left 4, so that's going to be negative 4, 1, and heading down there and heading up there. Okay. And then what does the negative do to it? So this negative right here will flip everything that's now positive, make it negative. So we're now down here at negative 4, negative 1, and we're going to head up here, still headed to 0, and then heading down forever. So the domain is still all real numbers. Yeah, it's an exponential. There are no problems. And the range is going to be the set of all y such that y is less than 0 right now, because that's still the horizontal asymptote y equals 0. All right, next one. Number 5, h of x equals negative 2 times 3 to the x plus 4. So here's 3 to the x. We're going to do that one right there. Good. A little bit too much of a corner there, but there's 0, 1. We're going to watch what happens. So we don't have any left or right shift affecting the x's, but we are going to multiply by a negative 2. So where that was a 1, it's now going to be, let's circle that so we can see what happens. That was up at 1. It's now going to be down at negative 2. So that's 0, negative 2 right now. And this going to 0 is still going to go to 0, and that's going to just be twice as tall, negative. Then let's see what this last guy does. This plus 4 now takes that 2 up to a positive 2, takes the 0 up to a Yeah, that's a y equals a 4, and it'll look like that. There we go. So we get that the domain is going to be all real numbers again, and the range in this case is going to be, looks like everything smaller than positive 4. Yeah, that's where our asymptote is right there. So we're going to hit, if you were to cast a shadow on this, we would hit all of these y values all the way down. Excellent. We could also write that as negative infinity up to 4, like that in interval notation. Okay, number 6. 1/7 times 4 to the x minus 2 minus 6. Oh, we're getting more of them. So 4 to the x is going to look like what we standardly start with, an exponential. And there's 0, 1 that we start with. Then we're going to next have, what does this minus 2 do to it? X minus 2 is going to move it right 2. So we're going to be over here at 2, 1. Still right along that horizontal asymptote of y equals 0. Okay. Then we've got a times by 1/7. So let's look at that. Timesing by 1/7 means it used to be up at 1. We're now down at 1/7. These guys are all 1/7 as big. And so we're like this. Yeah. So whatever was up here, we're now down 1/7 as tall. So probably a lot flatter. There we go. Something like that. And now we're going to finish off with a minus 6. So we're going to take this, and the horizontal asymptote now is going to be y equals a negative 6. And we're going to come through here and hit that point and go on up like that. So this point is now, it went over 2, and then it was times by 1/7, so we're 1/7, but now we're minusing 6. So 1/7 minus 42/7 would be negative 41/7. So we have, that's our point. That's what happened to 0, 1. Our domain then is all real numbers, and the range is, let's write it in interval notation. It's going to be everything bigger than negative 6. So from negative 6 up to positive infinity. And notice we do not include the negative 6 because it's that horizontal asymptote. Good. Number 7, e to the x minus 3. So e to the x works just like any of these other bases. E to the 0 is 1. So e to the x looks just like a normal exponential. Good. Now we're going to subtract 3 on it. Let's highlight that and see what it does. It moves the y equals 0 down to y equals a negative 3. Okay, there's our horizontal asymptote. We were at 0, 1. Now we're at 0, negative 2. And it'll go just like that and then head up. The domain is going to be all real numbers. It's an exponential. We have no problems. The range is going to be everything bigger than negative 3. So we can write it like this, y such that y is bigger than negative 3, or we can write it as negative 3 to infinity in interval notation. Okay, number 8. We're going to have an e to the x, and we're going to start with that. It's going to go like this. Notice now that this is an e to the negative x, which means, let's highlight this in another color, the negative is going to flip it, the x's that were positive to the negative, so it'll flip it this way and that way. So this is going to come down like this now. Yeah, so it makes all of these positive x's cause negative exponents on the e, and all the negative exponents are positive. All the negative x's will be positive exponents, making a very large number. Now we're going to subtract 3, this guy right over here. So now it's going to go down right here. Horizontal asymptote is again y equals a negative 3, and it'll look like this. So we were at 0, 1, now we're at 0, negative 2, and the domain is, again, all real numbers, and the range is going to be from everything bigger than negative 3. So y such that y is greater than negative 3, or negative 3 to infinity, like that. Good. The next one, number 9. We're going to start with e to the x. So let's get our e to the x in there. Good, and we've got our point 0, 1 that we're going to watch. Now it says we're going to do e to the negative x, which is going to do, yeah, that negative is going to flip all the x's around. So it's going to look like that. Good. There, the green is e to the negative x. Now we're going to multiply it by 2. So when we do this, it's going to multiply everything up here by a factor of 2. So this 0, 1 is now a 0, 2, and it's going to be very tall, but it's still eventually going to go to 0 because 2 times 0 is 0. Okay, and now we're going to subtract 4. So let's highlight that, subtracting 4. We're down here about y equals a negative 4. And this one is now, notice we were up at 2, and now we're going to be down here at 0, negative 2. Wow, the same one we were at the others, except now we're going to be going down through like that. There we go. So the domain, still all real numbers, and the range is the set of all y such that y is bigger than negative 4, or from negative 4 up to positive infinity in interval notation. Good. Number 10, we start with our e to the x, and we look and see what happens to the horizontal, and it was horizontally moved, opposite of what it looks like. That's a minus 2, so it goes 2 to the right that way. So we're over here like this with a 2, 1. So timesing it by negative 1/3, it used to be over 2 up 1. Now it's over 2 down negative 1/3. It just took that 1 and times it by a negative 1/3. So there we go. Probably a lot fatter like that. Okay, and now we're going to subtract 4. So the subtract 4 means it takes this guy and moves it down 4. So we are down about, let me see, y equals negative 4 is right here. There's our horizontal asymptote. And we're going to be just a third under that. So that point there is 2 out and negative 13/3 down. That's negative 4 1/3. So the domain is all real numbers, and the range is, everything less than y is such that y is less than negative 13/3. Oh, that's good. Or we could say negative infinity to negative 13/3, like that, in interval notation. All right, the next one. 5e to the negative x minus 7. So we start out with our e to the x right there. And we watch our point 0, 1. E to the negative x, it switches the x's places. So we've got this heading up like that. Good. Timesing by 5. What does that do to it? Timesing by 5 stretches it this way. It takes the 1 and makes it a 5, takes 1/5 and makes it 1, and takes those guys and shoots it way up very steep. Yeah, look at that. Okay, and that's the 5. And now what happens with that negative 7? It drops it down here. Instead of going along 0, it goes along negative 7. So it'll go like this and down like that. Well, where did we get to? This was 0, 1, got times by 5, was 0, 5, and now drop it down 7. This is 0, negative 2. And the domain is, all real numbers again. And the range, let me see, the range on the y value starts here at negative 7 and then goes up to infinity. We should write that as a horizontal asymptote. There we go. Or we could have written it set of all y such that y is greater than negative 7. All right, number 12, the last one. We have e to the negative x. So we've got to start out with our e to the x, our point 0, 1, like this. There we go. And the negative right here is going to flip the x's around. So it's going to look like this. Okay. And now the negative 3 is right here. So we're going to flip it upside down and times it by 3. So it's going to look like that. So this point is now 0, negative 3. It took this negative 1 and it flipped the y over and times it by 3. Good. And now we're going to add 7. So right here, this add 7 is going to take the y equals 0 and move it up here to a y equals 7. And then this is going to go like this. Good. And that's going to be, this was at negative 3 and it got moved up 7. It's 0, 4, like that. So the domain is all real numbers, and the range looks like the y's hit all of this, everything below 7. So we could write it as negative infinity to 7 in interval notation, or we could say the set of all y such that y is less than 7. And notice we don't hit equal to 7 because this gets closer and closer to it and never hits it. Good.